We're looking at the tube circuit here for the Trilogy 100 ventilator. The circuit we're going to look at today is the passive circuit. So what makes a circuit a passive circuit is the fact that it has a leak in it. So what I just want to show you before we go through all the components is the fact that what we've got here is airflow that goes through a bacteria filter, goes through a short tube, down to the humidifying chamber, and then it's connected to a heated tube, a heated wire tubing that is about 6 feet long. And then at the end, what makes this a passive circuit is the fact that it has a leak built into it. And that leak is made with this device. It's called a whisper swivel. And the whisper swivel comes apart. If I pinch the ends of it here, I can take it apart so it can be cleaned. And it is what provides the leak. Now, if you'll notice the way I have it in the circuit, I have the flanges pointed this way. What that does is allow the airflow to go this way away from the patient. You might wonder, why would I want a leak in a circuit when we're trying to ventilate somebody with positive pressure? The reason for the leak is to provide an escape for carbon dioxide. So if you think about it, without the leak in here, if we were ventilating a patient hooked up to the trach here, we would end up giving the patient the airflow, and they would breathe that air back into the tube and then breathe that same air back in again. So to prevent the buildup of carbon dioxide, we have this leak. So it's constantly flowing air out of it. So we've got a constant leak here of about 25, maybe 30 liters per minute, constantly coming out of the whisper swivel. That's how we're able to achieve ventilation and actually blow off that CO2 or the carbon dioxide. This is the same concept. If you know of anybody that uses a CPAP machine or a BiPAP, it's the same concept with that mask. Those masks have holes in them, and it provides a similar leak so that the CPAP or BiPAP patient is not rebreathing CO2 that way. So that's what a passive circuit is. So I just wanted to make it clear that we're looking today at the passive circuit for the Trilogy. So let's go over the different components so you know what we have here. So what we've got coming right out of the side of the Trilogy ventilator, this is where the airflow comes out, I've got a bacteria filter. This is a disposable bacteria filter. Filters down to very small particle size so that it's safe to provide that air right directly into a tracheostomy for a patient. And then there's a short tube. This one is about 2 feet long, and it is, think of it as a conduit, I guess, for the airflow that goes from the machine through the filter down into the humidifier. So the humidifier, what it does, I'm going to go ahead and take these tubes off, is heat the water. And the hotter the water, the more humidity we get for the patient. And we use typically this MR290 chamber, which is a drip feed chamber. The drip feed chamber fits into the 500 heater by pushing down on the lock here and then sliding the chamber back in. I'll then hook up my tube here and then my heated wire tube. Now you notice in the heated wire tube there is a probe attached here, and then there is also a heated wire adapter attached to the wire that's on the heated wire circuit, and both of them are plugged in to the side of the humidifier here. Nice thing about it, 2 different connectors, so we don't have to worry about which one goes where. They'll only go into one spot, and they are marked on the side of the humidifier. You might need to rotate this one just a little bit to get it to slide in. It should fit in nice and easy. And then we'll go ahead and attach our tube here, and then I'll show you the hookup for the heated wire adapter. Now these may be a little bit different depending on the type of circuit that you have, but the concept is the same. in that we've got this is our electrical connection going to the heated wire that is running through this tube all the way through. And the reason for the heated wire is to maintain the temperature all the way through, so we have less condensation. And then we've got our temperature probe, and our temperature probe attaches to a hole right on the top of the chamber here, and that is able to sense the temperature of the air coming right out of the heater, and that's one spot it's monitored. And then if you follow this tube, you notice this tube is quite long, it's about 6 feet long, this wire is about 6 feet long, and it goes all the way up to a hole that is in the tube circuit. Now that hole is part of the circuit, so you notice when I take the whisper swivel off, that is part of it. So the whisper swivel goes directly in here. Then we've got our temperature probe to fill that spot, and that's where it monitors the temperature right up proximal to the patient. And then I've got also added in here an adapter, which you may not have, but this is a nebulizer adapter. This is a spring adapter so that I can take this off and insert a nebulizer into this portion to give a neb treatment. You may not have that in your circuit, but pretty common to have. And then there's some type of a whisper, or not a whisper swivel, but a trach swivel adapter with a flex tube on it. And this allows attachment directly to a tracheostomy tube with some flexibility and the ability to swivel a couple of different ways so you don't put torque on the trach tube. So that completes our circuit. So again, the airflow is going all the way through into the humidifier. Temperature is being monitored here. The tube is being heated with this wire, and it travels all the way through, up through the whisper swivel, which remember, that's what makes a passive circuit with the leak. We've got our nebulizer adapter, and then our trach swivel adapter with the flex tube for connection to the patient.